Alright, I'm making this video to explain all the problems on your study guide so that you have some sort of way to go back and check your answers. Okay, so either you've completed all the problems and you're wanting to check your work, or there's some you don't understand and you want to know how to work them out. Okay, the point of this is not for you to copy down my answers only and get the credit. Okay, it's only to check for mistakes or to get help to get started. It should not be just to copy down. If only you copy down my answers, you're not going to be ready. Okay. So let's get started. Number 1, are the points W, V, and X collinear? If so, name the line on which they lie. So I'm going to go highlight where they're at. V, that's W, V, X. So it asks about collinear. What's it mean to be collinear? It means that they lie on the same exact line, all three of them. And clearly, these don't. They are not on the same line. Okay? Now, let's change the problem a little bit. What if instead it said W, V, and U? W, V, and U. If it said W, V, and U, we could say yes. So we would say yes, because they're on the same line. And then you could use any two of these to name the line. You could say UW with a line on top. Or you could say VW or WV, I mean, it really doesn't matter as long as you pick two that are on that line, okay? So remember, the blue was the original question. The black is just me thinking extra to show you that if they were collinear, okay? What is the intersection of plane WXYZ and plane VUZY? So let's go to our picture here. WXYZ, so let's find it. WXYZ. So it's the bottom. And then VUYZ. VUYZ is the front. Okay? We're talking about planes, so remember, planes intersect at a line. Okay, so we need to find out where these two planes intersect. Well, if we're talking about the front of this prism and the bottom, it would be that line right there. So we could say line YZ or ZY. Okay? It is important to note that when we're talking about a line, you must put these arrows on the ends. Tell me it's a line. If on this problem, I'm putting in red, so that's bad. If you told me this, I would give you like half credit if we were doing it like on paper, because you got the letters correct, but the symbol on top is not correct. That is a segment, okay? You have to put arrows to tell me it's a line. Okay. Next, name the line and the plane shown in the diagram. So if we're going to name a line, it's 2 points. Okay? So the only 2 points on that line are V and W, so we could say line VW or line WV. Okay? And then if we want to name the plane, let me back up for a minute. To name a plane, you have two options. You can either use three non-collinear points, or there might sometimes be a capital letter down here in the corner like a K or something. We don't have this option with the K, so we're not going to use it. In this instance specifically, we have to use three non-collinear points. Alright? So, one option could be VWY, or VWX, and then you can rearrange the order of those letters any way you want, okay? So just know for a plane it has to be three non-collinear points. Alright, that's it for that one. Number 4, which diagram shows plane PQR and plane QRS intersecting only at line QR? Okay, so the best way to do this one is just to go through and check each diagram and make sure it's correct. Alright. Let's start with choice A. Plane PQR, so we got that part, and then QRS. Is it intersecting at the line QR? So this intersection right here needs to be on that line QR. It looks like it's choice A, but let's double check. B, that's QP. Nope, that's not gonna work. That's RP. Nope. SP. Nope. So the choice is A. Okay. Now how do I know it's choice A? Because it intersects at line QR. So this point was Q, this point was R. That's how I chose it. Number 5, name the ray in the figure. Alright, when you name a ray, you start with the end point. Okay, remember a ray is a piece of a line that starts in an end point and then goes forever in one direction. Right? You start with the end point and then you pick a point down below it to name it. So we would call this ray CD. Okay? And then on top you put the bar with one arrow. Number 6, name the ray that is opposite BD. So, when it says opposite, we're talking about opposite rays. Opposite rays sharing the end point. So, in this ray, what's the end point? Remember, it's always what comes first, so it's B. This is ray BD. Right? I want to go opposite from it, so I have to start at B and go the other direction. Well, the only thing down here is A, so we would have to call this BA. Okay? Start the same endpoint and then go in the opposite direction. And notice that the two opposite rays make a line. That's a property of them. 4, labeled segments that are skew, that's an important word, to GC. So I'm going to first label for myself GC, find where it's at. It's right there. What does skew mean? skew lines are sorry, I'm getting it wrote out. Skew lines are non-coplanar and they're non-intersecting, so they're in completely entire different planes. That was a terrible sentence. I apologize for my language, my grammar. They're in different planes completely, and they don't intersect. Okay. Okay. So let's think about this for a minute. I'm going to have to think out loud for a second. We can't be in the same plane, so this segment, GC, is a part of this plane right here. Let me do it this bit differently. I don't like the way I was doing that. Here's what I'm looking at. This segment CG is a part of ACGE. It's a part of that. It's also a part of CDHG. Okay? So we can't use any segments from those planes. So I think BF is one. This one back here. I think FH is one. I think EF is one. There should be one more. And then AB. Then you're probably asking yourself, how did he come up with those? Well, I'm just going through in my head. These segments that I've listed out are not in these planes, okay? They're not on the front and they're not on the side. And I just picked four. I just picked the four, labeled them out with their points. Okay. That's it. Next, name the three labeled segments that are parallel to GC. So let's go label GC again. Okay, what's it mean to be parallel? Parallel segments or lines are coplanar and they're non-intersecting. You all know what they look like. I mean, they kind of generally look like this. Something like that. Okay? The first two should be really easy to find, okay? First one I see is DH. Because it runs the same direction. And it's in the same plane. The second one is AE. So let me see what else we got. DH, we got AE, and there's one more. I'm thinking about where it's at because I know what it is. I'm trying to think about where it's at. It's a diagonal plane. I'm trying to figure out where it goes through the figure at. Oh, here it is. This plane right here. It's diagonal through the prism. Okay? It's not one you can actually see. You kind of had to think for a minute to figure out where it's at. The third one is BF. Okay? So this one is from a diagonal plane. Sorry that took me a minute. I had to think out loud for a minute. Okay. Which plane is parallel to CDHG? So let's find it. CDHG. Okay, so if planes are parallel, they run in the same direction. So if we're talking about the front of this prism, it would be the back. So we would say AB, FE. Alright, next. Find BD. So two options here. You can use the ruler postulate, which states, it's basically this. Where is B? It's right here at -4. So we're going to use absolute value, -4, and then subtract. Where's D? D's down here at 8. -4 subtract 8 is -12. That's really 12. Okay, now if you don't want to do all this, just count your spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. So you can either do this ruler postulate with the absolute value, or you can literally just count. Either way. Alright, 11. This looks like a segment addition postulate. Okay? So in this diagram, we would say EF plus FG equals EG. Okay, so let's see what they want. So make sure you read the problem correctly and that you figure out what they want you to do. Find the values of X, EF, and FG. Okay? So let's look what they gave us. They told us EF is 2x minus 11. FG is 3x minus 10. And then EG is 24. So I'm going to plug in what I know. EF is 2x minus 11. FG is 3x minus 10. And then the EG is 24. Now we need to combine like terms. 2x's and 3x's gives me 5x's. -11 subtract 10 is -21. Okay, then we add 21. 5x equals, oops, bad math, sorry. That's 45. Divide 5. X equals 9. Okay, so that's one thing I had to do. So now it wants what EF and FG actually measure. So what you have to do is take this 9 that we just found for X and plug it back in for the X in both of these expressions. So EF was 2x minus 11. So 2 times 9 minus 11. That is 7. Because 2 times 9 is 18. 18 minus 11 is 7. FG was 3x minus 10. So 3 times 9 minus 10. 3 times 9 is 27. 27 minus 10 is 17. Now how do we know we're right? Well, if we add these two numbers together, we should get the 24 that was given. 7 plus 17 is definitely 24. So we've done it correctly. What point is the midpoint of AE? Okay, so midpoint means it sounds just like it is, the point directly in the middle of a line segment. So let's find out how long AE is. Now I'm just going to count here. A to E, if you count, that should be 16. So we're going to say AE is 16. Half of 16 is 8, so it's going to be the point that is 8 away from either end. And if I count, 1, 2, 3, 4, 5, 6, 7, 8. Yep, right here. Midpoint's D. Okay? Now, 13. If T is the midpoint of segment SU, find the values of X and ST. Okay? So midpoint, again, means in the middle. In this instance, we have two expressions, 7x and 4x plus 33. These two are going to be the same. So take your expressions and set them equal to each other. Move this smaller x. Then you would divide 3. You get x to be 11. Okay? So that's one thing we had to do, was find x. And now that wants to find st. Well, what's st? It's this piece right here, known as 7x. So we're going to say 7x, which is 7 times 11, you get 77. Okay? Now, another variation of this problem, you could say they would ask you for, instead of st, they could say, excuse me, they could want su. They would want the entire thing. Okay? So what you'd have to do is plug the 11 into both of these. So this one was already 77. And if you plug 11 back in here for the x, you get 77 again. What do two 77s make? So the whole thing will be 154. But that's only if they ask for the whole thing. Alright? Again, that was free with the price of admission. Alright, let's go on. This looks like an angle addition postulate question. Okay? So let's just read what it says. If the measure of angle BOC is 24, so I'm going to look at my picture. BOC, we're going to say that's 24. And the measure of AOC. Notice AOC is the big angle. It's 50 degrees. What's the measure of AOB? So, the measure of angle AOB plus the measure of angle BOC should equal the measure of angle AOC. Okay, this is the angle addition postulate. Alright, let's plug in what we know. Do we know what AOB is? No, we're trying to find it. So you could call it X if you wanted to. Or we could leave it alone. That's fine with me. Angle BOC they gave us is 24. And then AOC was 50. $50 subtract 24 should be 26. Okay. Simple angle addition. Alright. If the measure of angle DEF is 125, DEF EF 125. What is the measure of angle FEG and HEG, right? So let's list those out. Okay, so there's two things you have to find here. The measure of angle FEG and the measure of angle HEG. Alright, so let's look at our picture. FEG is right here next to the 125. And if you'll notice, the 125 and our missing piece make a half circle. And you should know that half a circle is 180. So those two are what we would call supplementary or a linear pair. They add up to 180. So I'm going to do 180 subtract 125. That gives me 55 degrees. Okay? Because the 125 plus this unknown made 180, I just did 180 subtract 125 to get that. Okay? Where is angle HEG now? HEG, that is right here. Let me do two different arcs. It's across from the 125. Okay? Remember I told you that if you kind of see an X, you might have to twist your neck a little bit to see it. There's kind of an X going on here. 125 and the HEG are across from each other. That means they are vertical angles and they're congruent. So if this one, if DEF is 125, well guess what? That means HEG is also 125 degrees. Right? Name an angle supplementary to angle COB. So let's go to my picture. COB. It's this one right here. Okay? If I want to be supplementary, I need to make a half circle. Okay? So I've already started a circle here, half circle here, so I'm going to just continue it until I get a half. Oh, there we go. Okay? I'm going to put another one here just to tell you that this is a different angle we're talking about. Notice that this arc goes from this ray to that ray. So the angle is going to be whatever points are on those rays. So to me it looks like it's going to be EOB. Okay? And that's because EOB and BOC together make a half circle. They're supplementary. In the figure shown below, the measure of angle AED is 118 degrees. So let's label that. AED is 118. Which of the following is false? So let's look. Angles BEC and CED are adjacent. So let's go back and look at our picture. I'm going to switch colors. BEC and CED. Are those adjacent? Well, what's adjacent mean? Adjacent basically means that the angles are sharing something. So angle BEC is right here. And then CED. Those two angles are sharing the side EC. So yes, they are adjacent. So it's not that one. Angle AED and BEC are adjacent. So let's look. AED. So that is what I'm doing in red right here. And BEC. Are those adjacent? It doesn't look like they are. Okay, it actually looks like they're vertical. So I'm going to put a dot next to this one because I think it's that one, but let's check the other two. The measure of angle AEB is 62. So where's AEB? AEB. Well, AEB and AED make a half circle. So they make 180. So what is 180 subtract 118? Whoops. Messed up on my calculator. It's 62. So it's not that one. Is angle BEC 118? Well, where's BEC? It's right here. And it is 118 because we have vertical angles from AED, okay, and BEC, so it's not that one. So the answer is B. Those two angles are not adjacent, they're vertical. How are the two angles related? So, they are not touching, okay? So it's not vertical, it's not adjacent. But they gave us two measures, so let's check the measures. What is 65 and 115 added together? That's what I think it is. Yep, we got 180. So these are supplementary. B. Alright. Number 19, the complement of an angle is 69 degrees. What is the measure of the angle? That word is key. Complement. It's related to complementary, which says that two angles add up to be exactly 90 degrees, okay? We know one of them, so let's just simply do 90 minus 69, 31 degrees. No, it's not. It's not 31. It's 21 degrees. I'm sorry. I did some bad math there. My apologies. It's 21. Alright. We got two angles that are complementary, and this time we have expressions. Alright. Anytime you have expressions, you're going to have to set up an equation. It's based on what this relationship is. Complementary means they add to 90. So I'm going to take x plus 5 plus x minus 7 equal it to 90. I see 2x's minus 2 equals 90. Add the 2. So 2x equals 92. $46. Okay, did we answer the question? So let's go back and look. Find the measure of each angle. No. So both angles have that x in them, so we're going to use this. So the measure of angle DFG is going to be our 46 plus 5, which is 51 degrees. The measure of angle JKL is 46 subtract 7, which should be not 40. Should be 33 degrees. And if you're unsure of yourself, double check. What's 51 add 33? And it's not that either. I'm sorry. See, even I make mistakes all the time, and I should go back and fix them. 39 degrees. There we go. Sorry. See, that's a good reason I did that, because I was unsure of my answers. 51 plus 33 did not get me to 90. But 51 plus 39 gets me to 90. And let's see. Now, on this multiple choice question, make sure that the numbers are in the correct spot. So we said DFG was 51, so it can't be those two. Could be any of those two. And then JKL is 39, so the only choice is A. Okay? Number 21 is similar, except we see the word supplementary. So that means we set up an entirely different equation. Let's take our measures. X minus 39. Add it to X plus 79. Now what do we equal it to? It says supplementary, so two angles are supplementary when they add up to 180. Let's combine like terms. Nope. I probably should stop doing this stuff in my head if I'm unsure of myself. 79 minus 39. Oh, it was 40. Subtract 40. 2x is 140. Divide 2. X 70. Did we answer the question? Let's go back and look. Find the measure of each angle. No. Both angles have that x, so we're going to have to use that. Measure of angle 1. Plug in our 70. Subtract 39. 70 minus 39 is going to be 31 degrees. Measure of angle 2, we put in our 70 and add 79. We get 149 degrees. Okay, and if this were a multiple choice question, just like number 20 was, make sure that the angle measures are next to the correct angle. Okay? Ray MO bisects angle LMN. Okay? This is an angle bisector problem, which means that whatever that angle is the same thing. So let's read what they tell us. Angle LMO, this angle right here, LMO, is 6x minus 30, if I can write. 6x minus 30. And angle NMO is 2x plus 30. Solve for x and find the measure of LMN. LMN is the whole big angle. Okay, so they want both pieces added together. Okay? Now, you have to set up an equation because you've got some variables going on, but the question is, what equation do you set up? We're talking about angle bisectors, which means this piece and that piece are the exact same thing. So we're going to take those expressions we were given and set them equal to each other and solve for x. Okay, so I'm going to move the smaller x x is 15. Okay? So now I have to take, you could do one of two things. I'm going to show you both ways and you get to pick whichever way you like to do it. Okay? First way is to take this x that we got, 15, put it in both of those expressions and add the two answers together. Alright? So let's do 6 times 15 minus 30. What's that give us? Let me see. 6 times 15 minus 30 gives us 60. And then 2 times 15 plus 30 Pretty sure that's 62. 60 as well, I mean. Yep, 60. You take these two, add them together. 120 is the final answer. Okay? If I were doing this, me personally, because I know this is a bisector problem, I can just plug the 15 into just one of the expressions and then double my final answer. So let me show you what I'm talking about. I'm going to pick this one just for, whatever, and I get 60. I would take this final answer and then double it. Okay? You still get the same thing. It's just, I think the blue way is a little bit longer, and the green way to me is a little bit shorter. That's just my personal preference. You do whatever you're more comfortable with. 23. Okay, we're not given a picture. So if I were you, I would... Oh, yeah, we are. It's down here. I'm sorry. It's way far away. Alright. Let's label this thing. We're still talking about an angle bisector. LMN. So LMN, the big angle, is 5x subtract 25. And then LMO is x plus 31. Find the measure of NMO. Okay? Well, they don't tell us what NMO is or what expression we could use, okay? But we secretly know what it is. You already know what it is. Because we're talking about a bisector, whatever we call this side, LMO, we called it x plus 31. You already know that this other side is also x plus 31, okay? You got two of those, so let's take both of those and set it equal to the expression for the big angle. Okay? So we got two x's and two 31s gives us 62. I'm going to move the small x uh, 87. And then divide 3. 87 divided 3 is, I don't know, 29. Now, does 29 itself answer the question? Let's go look. The measure of angle NMO. No, it doesn't, because NMO is represented with this x plus 31. So what do? It's like the Glade thing. You plug it in. Take 29, plug it in here, add them together. Should get 60. Let's see. Let me double check myself. Yep, 60. Alright. I'm going to erase this a little bit so I have some room for the next problem, because I think I'm going to need room. Find the distance between the points P at 8, 6 and Q at 7, 9. So remember, your distance formula looks like this. Big square root and then all that stuff underneath it. Okay? Now, I will show you two acceptable ways to put your numbers in, and then you just go straight to the calculator and type it in. Okay? So green is the first way. When I was taught to do this, I was taught to always start with the second point. So I would start with Q. Let me get a big old square root. And subtract the x's. So start with q. Q's x is at 7. So 7 subtract 8 squared. Then go back to q and do the y. So then 9 minus 6 squared. Okay? And then what I would do, me personally, is just do the little subtraction inside the parentheses. 7 minus 8, negative 1 squared. Add 9 minus 6 is 3 squared. Okay? And then from here, I would go to the calculator. Let's type this in. So big square root, open a parenthesis, put the negative 1, get out of there, squared, add. Now, because this 3 is positive, I'm not going to put it in parentheses, but you can if you want to. It's not going to hurt anything. Whoops. I got out from my square root accidentally. Sorry. Okay. And then I would round to the first decimal place. So I'm going to look what it is. It's a 1. And I'm going to look beside it. I see a 6, which means I would round the 1 up to 2. So I'm going to say my answer is approximately 3.2. Okay? That's the first way, and the way I was taught to do it, to start with the second point. Okay? It wasn't until much later, when I was actually teaching and in college and stuff, that you can kind of cheat. You don't have to start with the second one. You can actually start with the first one. So let me show you what that is. I'm going to erase the green. I'm going to switch to black. So it still starts the same. Big old square root. Let's start with the first one. The first point, P. So we're going to do 8 subtract 7 squared, and then add. Go back to the P, and then start with the Y's. 6 subtract, I think it's 9, yeah. Okay? Clean up the insides. 8 subtract 7 is 1 squared. 6 subtract 9 is negative 3 squared. So see just a little difference in it. Before in the green, this 1 was negative and the 3 was positive, and now it's flipped. But you should still get the same answer, so let's go see. So square root. This is positive, so I'm going to drop those parentheses. I don't need them. Gosh darn it. Get back under there. Square root 1 squared, add, parentheses, negative 3, get out parentheses, square it. I get the same thing, 3.2. Okay? Either way you want to do it. Works for me. Don't care. Okay. Each unit on this map represents 5 miles. So what that means is one little space is 5 miles. Alright? What is the actual distance from oceanfront to seaside? So let me get this off. Oceanfront to seaside is through here. We can't count it, okay, because it's diagonal. So we have to use our distance formula again. Right? Now, I'm going to list out the points where these are at. So seaside is at negative 2, 4. I can read correctly. Negative 2, 1, 2, 2. Yep. And then oceanfront is at, well, I've made my marker too big. I got to erase it. Oceanfront is at 3, -2. Sorry. Alright? Let's use our distance formula. Doesn't matter where you start. I'm going to start up here just because it's on top. So I would do -2 subtract 3 squared, and then add. Go back to where I started with -2, so I go back to its y. I would do 4 subtract -2 squared. Alright? Clean up the insides. -2 subtract 5, or -2 subtract 3, excuse me, is -5 squared. 4 subtract -2, that's secretly 4 plus 2, which is going to be 6 squared. Now I'm going to go from here, type in my calculator, square root, that 5 is negative, make sure I'm under there. Now, my 6 is positive, so I'm just going to drop those parentheses, I don't need them. Well, shoot. Sorry, sometimes I forget I accidentally come out from underneath the square root and have to fix it. Alright. Rounding that answer is about 7.8, so let's go back. So instead of equal, I'm going to say approximately 7.8. Now, if we're just going to round that up, we could say that's about 8. Now, I want you to notice, 8 is an answer, okay? And I'm pretty sure a bunch of you would have chosen 8. But look at what the problem said. Each unit represents 5 miles, okay? That means each little space on here, whether it's horizontal, vertical, or diagonal, is 8. Okay? We have to take that 8 and multiply it by that 5 units. Okay, this is really 8 units. So 8 times 5, which we all know is 40. So the actual answer is B here. Be super careful with this problem. Make sure that you remember to multiply it by your units. Okay? Let me double check something real quick. Yeah. Last 3. Find the coordinates of the midpoint of the segment whose endpoints are at 4, 4, and 8, 6. Okay? So remember the midpoint looks like this. Your answer is actually another point. Basically, you add your x's up, divide them by 2, then you add your y's up and divide them by 2. Alright? So 4 plus 8 divide 2. 4 plus 6 divide 2. Now, if you're going to do these like by hand, start on the top, do the addition, and then do the division. Okay? 4 plus 8 is 12. 12 divided 2 is 6. 4 plus 6 is 10. 10 divided 2 is 5. Okay? I'm going to show you real quick on the calculator. If you wanted to type these in, if I were you all, I would hit this A over B button, and then do the addition on top, then go to the bottom and hit divide 2. There's your answer, 6. Hit it again for the y's. 4 plus, I don't remember what it was, 6. Yeah. Okay, I gotta start over. Sorry. Shoo! Sorry. 4 plus 6. Get out of there. 2. I get 5 again. Okay? So that's if you want to use the calculator. These are usually pretty easy enough, you can just do them in your head. Find the midpoint of PQ. Okay, I'm going to list where the coordinates are at. So P is at 1, 2, 3, 4, 5, 6, 7, 8. -8, -2. And then Q is down here at 2, -8. Alright? So the midpoint, let's take our x's. We've got -8 plus 2 divide 2, and then -2 plus -8 divide 2. And again, you can use the calculator, but I'm just going to do this in my head because it's faster. -8 plus 2 is -6. -6 divided 2 is -3. 3. -2 plus -8. That's secretly -2 subtract 8, which is -10. Then -10 divided 2 is -5. Okay, if you just want to graph it, you don't have to graph it, but it's right there. Just to show you where it's at. Alright, I'm going to erase this over here because I need some room. Now 28 is a special case of the midpoint problems that we didn't necessarily do, but it shouldn't be that hard. You should be able to figure it out. Alright. They tell us M at 4, 4 is the midpoint. Okay? They tell us that the point S, one of the endpoints, is at 7, 6. Where's the other endpoint? Alright? So remember, the formula looks like this. Let me write it again. Okay? So let me show you how I work it out, and you should be able to get it from there. They told us what M is, so I'm just going to take the M out and put the 4. Okay? And because they told us an endpoint, we already know what one of these X's and one of these Y's are. Alright, so I'm just going to plug it in. 7 plus x2, and then 6. Okay? What you have to do is remember that this first 4 on the X goes with this equation, and then this Y goes with the other equation. Let me make me some room. I'm going to have to write on top of this because I have no room. Okay? What I'm going to do is take each of these coordinates and set them equal to each other. So we're going to say 7 plus x2 divided 2 equal 4. I'm just going to do the first one. Alright? When you have an equation like this, I know it's been a while since you've done equations, but in Algebra 1 you learned these. When you have this big division bar first, you start down here with division. Okay? If I'm dividing by 2, I'm going to multiply by 2 up, by 2 up here. Oh my gosh. Sorry. My board did not like that. Multiply by 2 up here, and my 2 over here. Okay? In doing that, those two 2's cancel each other out. So you get 7 plus x2 equals 8. Then you subtract the 7's. x2's at 1. Okay? So R starts at 1 as the x. Now let's go back and do this for the y. I'm going to do it over here. 6 plus y2 over 2 equals 4. Let me just separate these out. Again, times 2. Those are gone. 6 plus y2 equals 8 minus 6. We get y2 to be 2. So there's the coordinates of R. Okay? I know that looks kind of confusing. Okay? I'm going to do one more, just make one up off the top of my head so we can see how it works. Okay? So that's the last one. So let's say M is, I meant to write midpoint, I started to write something else. We're going to say M is the midpoint. We're going to say M is at, oh, I don't know. Let's say it's at 5 comma negative 2. Okay? S is an endpoint. We're going to say S is at I'm thinking. This is what happens when I come up with one off the top of my head. Let's see what happens with that. Again, I literally just made this up, so I don't know if it's going to work out pretty. Okay. So we have a midpoint and an endpoint. We want the other endpoint. So let's come down here. Our midpoint was at 5 comma negative 2. Okay. Now remember, to get this 5, we had to take both our x values and divide them by 2. We know one of them. So 12 plus the second x, divide 2, had to be 5. Okay? I'm going to change that because I think I'm going to get a really big number. Let's say s is at negative 2, 4. There we go. So we had to take negative 2 plus the second x, divide it by 2, and get to 5. Okay? We had to take 4 plus the second y and divide it by 2 and get to the negative 2. Okay? So here's what you do. Take the x coordinate of the midpoint, set it equal to this mess over here. Okay? And basically all you do is take the 2 in the bottom, multiply it by the 5 over here. So take that, multiply it by that, you get 10. And then whatever was on top, you just leave it alone and drop it down. Okay? And then add 2. 12 was x2. Right? Do the same thing for the y. So we had negative 2 equals 4 plus y2 divided 2. Take this 2 in the bottom, multiply it by that over there, and then drop the 4 plus y down because he didn't mess with it. Subtract 4. So negative 8 is the y2. So now we know that point R was originally 12 comma negative 8. Okay? Alright, that's the entire study guide. Okay, plus one extra for your benefit if you wanted some help with that last problem. Okay, remember, this video is only to help you check your answers or to help you get unstuck on a problem. It should not be that you just copy my answers down to receive credit, or otherwise you're not going to be ready for the test. Alright? Hope this video helps with your study guide, study hard, and good luck on your test.